Hi, I'm Dr. Alexander NGENZI from University of Rwanda College of Science and Technology, Department of Computer and Software Engineering. Okay, at this time we are going to explain the first Fourier transform. If I can just begin explaining how it came in and what was the main purpose of FFT and what is its advantage. Those are the points that I'm going to discuss so that I can give you a full description of what it means. First of all, there were they tried to develop different algorithms to overcome the problem of DFT. You remember it was a time consuming, so the different algorithms were developed, and one of them was FFT to solve this. First of all, it reduced the number of computations. Secondly, it is not time consuming. It reduced also the number of time that was supposed to take. Suppose if the time was to take hours and hours, in this case, it took less time. And also, it brought some features, and therefore, the features were intended to reduce the time that was supposed to be taking a very huge period of time. And in this case, it was very fast. First of all, it was very fast. It is less time consuming. It was less to reduce the number of calculations, and also it was a user friendly. And that's why the FFT was coming in. But it is built on the same platform with the DFT. Only this one is enhanced feature to overcome all those problems. So now let us see the next point, which is first Fourier transform. First Fourier transform algorithm. So this is what we are going to discuss as our second point, as I have introduced. So in this case, as I mentioned, we said it is one of the solutions that was developed to overcome the DFT difficulties. Among those difficulties were the big any computations or the huge calculations. So it solved some of the problems. It's first of all, solutions that came in was less calculations. So the big N times was reduced, is reduced to a smaller N times, so that the number of calculations are reduced. So the frequency domain can have F1, F2, F3, and each one of these ones can be effectively computed on their own with less time. So there is a less calculation, there is also less time. It is very fast, less time. It is less time consuming. Also, the calculation also can be reduced in a very effective way. It is very fast, efficient. So it increases the efficiency of computations, or calculations. So These are very, very important. So it came up with solutions which was hindering DFT algorithm. So this is very, very important to note about the FFT, and it's very, very important to also to understand that FFT was one of the best algorithms that was developed to overcome the DFT algorithm. So remember, if you can recall, this is what we discussed last time, but also I can repeat them. Remember the n times. For example, if we have, for example, a small table here, having you can have like how many columns? You have n column. You can have also the time in DFT. We can also the time in FFT. We are trying to compare how fast is this algorithm and how it is efficient. For example, if we have n computation of 2 power 12, for example, in this case, those are number of computation. How much time is it going to take in DFT, and how much time is it going to take in FFT? Oh, sorry, I forgot to put this T. So we are going to see the beauty or the advantage of having FFT algorithm compared to the predecessor, which is DFT, having a number of computation this side. So suppose if you have to compute such a huge number of discrete values, that is ranging from 2 power 12, for example, it's going to take, in DFT, it's going to take 8 seconds. It's going to take 8 seconds in this case. And you can imagine what will be the time period in FFT. Do you know what's going to be the answer here? It's going to be very less. So the time is going to be reduced. As I said, one of the time, it is less time consuming in this case. So it's going to be 0.013 seconds. So you can see it has reduced so much in this case. So that is an example number one. So, and again, you can have, for example, if it is 2, a number of competition are ranging from 2 to power 16, then it's going to take like 0.6 hours. Remember, for DFT, you can guess what will be our FFT. Do you know what is going to be the answer? So I'm just showing you these are the advantages of FFT in terms of computational time, in terms of also its efficiency, and in terms of the number of calculations in this case. So it's going to be here, it's going to be 0.26 seconds. Yes, it's going to be 6 seconds. So you can see these are the hours, but it has been reduced to even very small quantity of at the FFT. We can also, like for example, another big computation here, which is 2 power 20, or 2 raised to the power to the power of 20, 2 raised to 20, and then you can have how many time that is going to how much time is going to take to overcome this in DFT is going to be 6 days. You can imagine 6 days. But guess what is going to be our FFT? So you can guess what is going to be our FFT. It's going to be only 5 seconds. It's just like a small period of time. It's going to be very reduced, so yet only 5 seconds. You can imagine. So you can see this column for FFT is very, very small. It's going to be very small, and therefore it's very useful to understand that this algorithm was very effectively in terms of computational calculations and time consuming, and the effectively or the efficiency of the system. So this table shows that DFT was not a solution to compute a very big or the large numbers of the n times or the discrete values. Instead, they tried to come up with a very good algorithm on this in this case. So that's why they developed this this table, I think. I hope this is understood, and you have seen the beauty of having FFT algorithm compared to its FFT algorithm. So I hope you have understood what we discussed about the FFT, which is a fast Fourier transform. We said it was one of the algorithm that was developed to overcome the problem of DFT, which included the time consuming. It took a very huge period of time. Even the number of computations were so huge, and also its efficiency was also very less. So the FFT came in to solve all those problems. As I said, I have also highlighted and showed you the table, its table, and how it is compared depending to how many number of computation and how many in which time period it takes to compute the very big number of n. So remember, there was 2 power 12, 2 power 16, 2 power, and all those were having different time values corresponding. And what we have seen is that in the FFT algorithm is very reduced. The time was very reduced to the extent that if you are to advise people to use some of the best algorithm, we can also recommend the FFT. So I hope you have understood the essence or the usefulness or the beauty of FFT. So the next portion is going to be the decimation in time domain, both in DFT and FFT. So this is going to be the next point to be discussed.